All right, I'm sharing my screen.
And Kenneth, can you see the screen again?
Okay, good.
Sounds
All
good.
right. Hello, everyone. Thanks for joining. And today's topic is how to maximize or improve performance using read-committed snapshot isolation levels. And before we dive into the topic, I'll just tell you a little bit about myself. This is Haripriya. I've been working as a SQL database administrator for almost 12 years now, based out of Boston. And I actually started speaking a couple of years ago with New Stars of Data. That was my first time on the stage speaking. And then I got opportunities to speak at a few SQL Saturdays, past Summit, and events like that. And I also write technical articles, especially about SQL Server. And nowadays, I'm also, as I'm trying to learn Postgres, so I'm just writing some articles about Postgres as well. So that's about me. And this whole slide deck and the demo scripts, you will find it on GitHub. And in case if you have any questions, you can feel free to DM me on LinkedIn. And MVP, yes. I got the MVP award from Microsoft in data platform. That was last year. That was the first time I got this award in 2025 for the speaking and blogging that I've been doing about SQL Server. All right. Okay, let's go ahead and discuss the problem that we are having. So if you see on your production servers, you will see blocking issues. When we talk about blocking, there can be so many different types. But the blocking that we will be discussing today is about read versus write blocking. So before we go any further ahead, I just want to show you what the agenda for this session is going to look like. So the first thing we will see is what is the default isolation level, what's the problems with that default level, and why we are considering RCSI, which is read committed snapshot isolation level, how it works, what are its advantages, disadvantages, how version store comes into play, what are the trade-offs, the things that you have to be cautious about before enabling RCSI, and many other things like that, how you would do things on your production server especially. All right, so that's the agenda. And this is more like an intermediate level. I just expect the attendees to know just the basic working, not about all the isolation levels, but just about how, the basic understanding of SQL Server. Isolation. So since we are discussing about isolation levels, I want to tell you first, what is an isolation? So when you have transactions running, we don't want those transactions to be interfering with each other. So they have to be separate and they need to finish. So that's what these isolation levels are all about. With the locking and multiple things that come in, we will be seeing how to separate those isolation levels. So based on the locking model, we have 4 isolation levels: read uncommitted, read committed, repeatable read, and serializable. Based on the locking and row versioning model, we have 2 levels, which is read committed snapshot and snapshot. And in this session, we are very much interested in read committed snapshot. But before that, we will take a look at what is the default isolation level of the engine S, which is nothing but read committed. That means, like the name tells, it reads only committed data, and whatever you write, it will write only on committed data. All right, so whatever the transactions run, they will run or they will work only on committed data. And that's what read committed is all about. And let me show you visually here. So what the problem is, maybe I shouldn't call this a problem. This is how the design of this read committed isolation level is. If you were to run an update statement, it always needs an exclusive lock. And concurrently, if you run the select statement, it needs a shared lock. So what happens in this case is When you check with SP who's active or any of your favorite blocking queries, you can see now that the select statement is blocked by the write statement. So this is what we call it as read versus write blocking. And this is how it works with this read committed isolation level. When you have an update statement running and concurrently a select statement running, they will get blocked. So what can we do to resolve this? Well, there are a few ways. And keeping the transactions very short is really important no matter what the isolation level is. Query optimization, we all know that's again important, and you have to add enough number of indexes. So even when all these are in place and you still have read versus write blocking, which I'm sure you will, especially on production servers when there is high concurrency, then the solution to this is read committed snapshot isolation level. This will get rid of the read and write blocking. Let's take a look. So if you have RCSI, this is what you will be seeing on your database properties screen. If you see this, I can zoom into this a little bit. You will see this is read committed snapshot on as true. So that means RCSI is enabled. And also there are a few ways you can check, like for example, select this from databases. You will see this read committed snapshot on as one. And then you can also do DBCC user options. This is one of my favorite ways to check. I just do DBCC user options because especially for the query window or how things are, it tells you what the isolation level is. All right, let's see the design, how it works. Imagine you have a table called T1 with column ID and column letter. And you have TempDB database. It has, the work tables, hash tables, internal objects, version store, everything in TempDB, because that's how it is in SQL Server. And now you want to run an update statement. And this database is RCSI enabled. All right. So when you run the update statement, usually what we have, the update statement will just run and finish. But on RCSI, what happens is the first step is to copy that row into the version store. Whatever the previously committed value is, this will get copied into the version store. Now, step 2 is to run the update. So the first thing is copy the data to TempDB's version store and then run the update. Now what happens is write will always go to the table, the original table in the database. Read will go to the version store. Now there is no read versus write blocking. So this is how RCSI works. If you go back to the default isolation level, there is no copying step here. Nothing will go to the version store. The first thing is to just run an update, and when the select runs, it will get blocked because the select also reads from the original table in case of default isolation level. But because this is RCSI, write will go to the table, read will go to the version store and read this previously committed value. So this is how we are preventing the blocking. Let's take a few scenarios. Take a look at a few scenarios here. The first one is when you have a write operation coming in to an orders table, you run an update statement and it is going to get the exclusive block. Before it runs the update, just like how we saw now, it will make a copy to the version store. Now, when the select statement comes in, it will read from the version store. All right, we all know the scenario now on RCSI. Let's take a look at the second scenario. All you have is only read operations. Now, will this go to the version store or to the user table? Let's look. So there are no concurrent operations, which means no write operation or anything going on simultaneously. What happens? The select directly goes to the orders table and it will read the data from orders table. There is no need for it to access version store because there is no update or delete running and there is no previous copy in the version store. All right, so just because it's RCSI, that doesn't mean select is always reading from the version store. only when there are concurrent operations, then the select statement reads from the version store. Third scenario, you have read coming in first. Now it is reading from the table. What if you have write coming in? Now the write will get blocked, right? But that's not the case. What happens is now the copy of the table for which the IDs it is looking for, it will, I mean, for which it is going to be updating. Now that copy will be made to the version store. So what happens? Select immediately moves to the version store. All right. So basically the point here is, even if the select is reading from the original table and if the write is coming in, the select will go fetch its records from the version store and will never get blocked. So that's the basic idea of RCSI. All right. Okay, so here I want to show you a table. This is RCSI enabled database. I insert a couple of records and I do DBCC page just to check the, how the internals of the page look like. You will see this versioning info, which means this is RCSI because it will have a version of the record when you do an update or a delete. And you see this version information. Version pointer is null. Because this is an insert statement, it does not need to do any previously committed copy into the version store because there is no previously committed copy for an insert. So it says version pointer null. Now, if I run an update on this same table, what happens is, you see here, you will see where the version pointer is. The previously committed copy is saved in tempdb. This is the difference. So in RCSI enabled database, whenever you run the update statement, that record before the update will be copied into the tempdb. All right. So in short, if you don't want to mess around all these details, the idea here is read goes to the version store in tempdb and fetches the records from there, and write operations go to the user table in the database. So there's no more read versus write blocking when you have RCSI enabled. All right. And when should you use RCSI? Like we just discussed, when you have read versus write blocking, usually you would see that on very high concurrent, critical OLTP servers. And if you have like a lot of queries, if you have a lot of select queries, constantly reading the data, then they would be blocked by the update statements that are coming in. So usually you would see this on OLTP servers. And this is actually the default isolation level in Azure SQL and Postgres too. Before moving further, anyone has any questions?
No, I don't see any questions. It's just individuals are having some problems. We know that we have the problem with the teams and some of the sharing.
Okay.
If there are some people with their hands raised, if you could type your questions into the chat, then we can answer them. But we are aware of the team sharing, and sometimes it's working and sometimes it isn't. This is being recorded and will be posted to our YouTube channel. So I think you're fine to move on.
I'll go ahead. So who blocks who? In read committed, which is the default isolation level, read blocks, write blocks, read, everything is there except for read in read, which never gets blocked. And I also want to tell you with RCSI, write operation behavior, the locking behavior always will remain the same. So write will be blocked by another write. All right. What changes in RCSI is only the read versus write blocking is prevented. So if you compare between the default isolation level and RCSI, you will see that, how read versus write blocks are prevented here. So because we are talking about read committed isolation, read committed snapshot isolation, let's also take a look at the snapshot isolation level. So this is a bit different. And what you have to do is you have to enable allow snapshot isolation true. In RCSI, if you see, this will be true. But for snapshot isolation, this will not be enabled. It's just the allow snapshot isolation will be enabled. And what this means is the select will not automatically read from version store. Only if you set this transaction isolation level snapshot and then write the select statement, now this select will read from the version store. So that's the difference. In RCSI, any select statement, it will automatically read data from version store. In SI, you have to explicitly mention this set transaction isolation level snapshot for you to read from version store. If you don't write this, then it will just behave like a read committed, default isolation level. So that's the main difference. Well, if we have to speak in simple words, read committed means you read the committed data from the table. Read committed snapshot means you read committed data from the snapshot. And snapshot isolation means you're reading the committed data from the snapshot only when explicitly set, like you have to write that statement, set transaction isolation level snapshot. So that's the difference between these three isolation levels. Version store. I know the moment you hear about version store, it's like there are always issues. You have to set up alerts, monitoring, and all of that, which is true because there's one very important issue that you have to know about version store, which is any long open transaction or uncommitted transaction. That is, either of these is always an issue that will blow up your temp DB. All right, so that you have to be very cautious about, especially when you enable RCSI. Let's take a look why that is even a problem. The version store, why it is filling up, and it blows up the server, many things like that when you always have version store enabled. So I'm going to show you, like an analogy here. That way it is easy to understand. Imagine this is a single lane road, one way. You have cars there with the red light. And if you notice, there's a red car where the driver is sleeping. The reason I mentioned sleeping is because I want to connect that to a sleeping transaction. And now you have a green light. The first three cars moved. Anything that's behind the red car cannot move. All right. Now just have this in mind, because what I'm going to connect this to is, if there is a sleeping transaction, just like this red car, any transaction behind it cannot be cleaned up. And that's how tempdb data file space gets filled up and it becomes inaccessible, which I'm going to show you right now. This is just a table for only for understanding purposes. I put it in a very simple way. You have time, transaction ID, status of the transaction, and how many gig it consumed, and what's the database it is from. So you have multiple transactions from different databases that have used the version store. Now the version store cleanup task runs. This cleanup task always runs in the background, trying to clean up the version store, which means it will free up the space in tempdb. So when the cleanup task runs, the first three transactions get cleaned up because they are committed. Only the committed transactions can get cleaned up. So the first three gets cleaned up and you get that 2 gig, 3 gig, and another 2 gig. All those get released. Now the cleanup task runs again, but it cannot clean up anymore because the fourth transaction is not committed. It is sleeping. The cleanup task runs again, and none of the transactions after the fourth transaction can be cleaned up. None of them can be cleaned up. Everything will stay there. It's because the first transaction or the previous transaction should always be committed for everything else to be cleaned up. The moment you have a sleeping or uncommitted transaction, nothing behind it can be cleaned up, regardless of the databases it is coming from. So that's the very important point that you always have to remember when it comes to version store in TempDB. That's because TempDB is a common resource for all the databases in that SQL Server instance. So if you're thinking, oh, I ran it only from, Stack Overflow database, why is even AdventureWorks not, why is it even not cleaning up there? No, whatever database it is from, the first or the previous transaction needs to be committed for everything else to be cleaned up as well. That is why I said if you want to reduce issues with version store, you should always make sure you don't have issues with any uncommitted or long open transactions. So yeah, it is like, you're trying to fix the read versus write blocking, but eventually you end up with blowing up the TempDB, because that's what I did once. I remember it so well. So, it's good thing that you can enable RCSI, but before doing that, you should also know the trade-offs that come along with it and the things that you have to monitor. So monitoring and troubleshooting, there are a few DMVs that you have to keep note of. So what I do is I usually set up some alerting with the SQL Server jobs or PowerShell. You can do whatever suits your environment. But the point here is you have to check the version store usage, like how much space is being used. You can set up alerts like, 60%, 70, 50, like whatever number suits you. You just have to do some testing with your estate and see what helps. And you can also get those monitoring scripts there that I use on my production servers. So probably you could use it and tweak it like however you want it. All right. So to summarize, if you have read versus write blocking, you can use RCSI at the same time. Just remember, you have the trade-off that version store TempDB usage needs to be monitored. You cannot have any uncommitted or open transaction for a very long time, because that's going to stop the cleanup from happening. Any questions before I move ahead? Let me check.
No, I don't see anything.
All right. Okay. And the other thing is no log, because it's almost everyone's favorite hint to use no log, especially on your select queries. You can use no log when you don't need accuracy in your result set, because with no log people usually think, oh, it's super fast and things like that. That is not the case. No log means it reads uncommitted data, the data that is not committed yet, which is also called a dirty read. So that's why people use no log, and importantly, because it does not cause blocking, right? So when you have RCSI, that purpose is resolved. When you run the select statement, you are not going to block anything else. So in RCSI, you don't have to use the no log hint. So that's what I'm saying. And also there is some, trade-offs with no log. You could use it for archive data, or you're just loading table into a staging table or something, and you just want to check the progress. For all those things, you could use no log. But if you're working on, mission critical OLTP servers, very important data that all you need is accuracy, then do not use no log. And if you're worried that your queries are going to block other transactions, then enable RCSI on your database. All right. You can take a look at the demo. I'm going to bring up SSMS. All right, so like I said, I will show you the DBCC user options right now, what I have. And if you see this last column here, you see read committed, that is the default isolation level. Oops, what did I do? All right, let me go back to this. The default isolation level. And what I'm going to do now is select from T1. I have 10 records in there with 3 columns. I'll just do an explicitly open transaction just to show you the blocking and things like that. All right. So I'm just updating one ID, and let's review in the other window. I'm just running a select statement on the same ID where the update is running. because this is default isolation level, now this select statement will be blocked. This is blocked because in the first window, this update is still open. It's not committed yet. That's why the select is still spinning, because this is blocked. Let's also check the log now. And I usually use this SP who's active. And if you see now, you see this, the select statement, it's actually waiting for the shared lock. All right. So this is how read committed, which is the default isolation level, works. So that's what I wanted to show you. The problem that we discussed in the beginning that we are going to solve is this read versus write blocking. All right. So let me go here now, and I'm going to commit this update statement that I just ran. So it'll be committed. And if you see, this select would have grabbed the records. And now we should not have any blocking. All right, so this is how read committed works. Now I'm going to show you in RCSI how this kind of blocking does not occur at all. So if you check, I don't have RCSI enabled yet. This is 0, which means this is disabled. And what I'm going to do now is, before enabling this, we have to make sure we don't have any active transactions. And set read committed snapshot on is what will enable RCSI. And to run this, I highly recommend you do it in off hours or maintenance windows, because you cannot have any active transactions running on this database. So I'm going to go ahead and run this. It usually takes like a few seconds. It checks, if anything is active, and then it enables RCSI. So again, when you run this, you need to have exclusive access. All right, so this is enabled. Let's verify it. If you see now, this is 1, which means read committed snapshot. This is enabled. And if you check the DBC's user options, now this is changed to read committed snapshot. All right, now what we are going to do is, again, I'm going to keep it open and run this update statement, which means this is not committed yet. On the other window, I'm going to run the select statement. Because this is RCSI, now this will not be blocked, and this will get the data from version store. So that's the key difference here. The selects will never get blocked, even though there are concurrently update operations running in RCSI. That's because the select can read from version store. All right. And if you also check the blocking, you wouldn't see anything at all. See, we don't see any blocking here at all. It just shows you like a transaction is running and there's no blocking. So that's the key point with RCSI. You will not see select and update getting blocked. Even though this is still open, I'm going to go ahead and run the commit. Right? And before it cleans up, I can also show you in version store. Usually it takes a minute to clean up after the active transaction finishes. So DM tran version store, now you can see number of version rows 1. Because we ran the update statement for 1 row, you see that 1 row is still here until it gets cleaned up. And this DMV here, version store space usage, also shows how much space was consumed in the version store, 64 KB. And you can also use this active snapshot database transactions. Okay, we don't have anything because it got cleaned up. I committed, right? And if I can also do it again. Let's see. If I just do it again here. Okay, now this is open. So if you see, now I should see something. Yeah. Because I left the transaction open, a copy is still in the version store now. And if I run this, you see this session ID 66 DBA test. This will show you like what's going on, how long the transaction is for. So usually on production servers, what I do is I use this query here to check how many transactions are using the version store, or how long a transaction is open. It's good to identify what is open, and if anything is lingering around for so many hours or days, the cleanup does not run. So we have to make sure these transactions get over quickly. All right. So that's about this demo. And let me go back to this. So the takeaways here are: the default isolation is read committed, but because we have read versus write blocking, you can use RCSI. And only the read versus write blocking is avoided. For write operations, locking behavior is always the same. And as you enable RCSI, you have to make sure you are monitoring the space usage of version stored in TempDB. And if there are any uncommitted or long open transactions, make sure, again, you're monitoring that and taking care of that. That way your TempDB does not blow up. And when you are using RCSI, there is no need for you to use no-log because you're not going to cause any blocking. And if you use no-log, then it does not honor the RCSI isolation level anymore. Because when you use no-log, means you're going to read uncommitted data. It's almost like read uncommitted isolation level. Right? Any questions?
No questions.
All right. Thank you, everyone. That brings us to the end. Again, the slide deck is on GitHub. So, if you want to go take a look, and I have many more scripts for demos that you can also try out if you're interested. Thank you.
The recording will be posted to our YouTube channel. We'll try to get that up to date as quickly as we can. I want to thank everybody for attending and thank Haripriya for a very, very good presentation, very clear and precise, as far as explaining the different isolation levels. I really enjoyed listening about the demo and everything. And we will be working on getting the Teams screen sharing fixed on the different browsers, mobile and desktops. Thanks again to everybody for bringing it to our attention. Thank you so much for your time. I really appreciate this and for the presentation. And everybody take a look at our calendar and we'll see you in June. Thank you very much.
All right. Thanks, everyone. Bye.